Now let's take our sum and difference identities and apply them in a couple of different examples. The first one I want to talk about is I want to be able to write the expression as a single function of x. In other words, I want it to get rid of these two terms. I want to make this a single term, and since we know we can't use the distributive property on this, we have to use our new identities. So I can rewrite this example right here so that it looks like, using the sum identity for sine, it's going to look like the sine of the first, which is 5 pi over 6, times the cosine of the second, plus the cosine of the first, times the sine of the second. Well, I can simplify 5 pi over 6, or the sine of 5 pi over 6, by rewriting that as 1/2 times the cosine of x, plus the cosine of 5 pi over 6 is going to be negative square roots of 3 over 2, so let's change that to minus the square root of 3 over 2, times sine x. Okay, now hopefully you see I'm going to take, since I have two fractions here and both these fractions have the same denominator, I'm going to rewrite this so that it looks like the cosine of x minus the square root of 3 sine x all over that one denominator of 2. I hope you see how I went from this right here to this combined single fraction down there. And that's really all we're doing. Let's try that again for the next example using tangent. So again, I want to rewrite this so that it looks like a single function, or a single function of theta, using the sum identity for tangent. Let's rewrite this so that it's the tangent of the first plus the tangent of the second divided by 1 minus the tangent of the first times the tangent of the second. So now we go through and we simplify this. Well, the tangent of theta is just going to be the tangent of theta. And what do you think the tangent of 3 pi is? Well, let's think about that for a second. If I start here and I go all the way around the circle, that's 2 pi. And if I keep going around, that's 3 pi, isn't it? Which is the same thing as pi. So in other words, the tangent of pi is going to just be 0. All over 1 minus the tangent of theta times 0. Well, this is just going to be 0. So 1 minus 0 is just 1. And we leave the numerator as just the tangent of theta. And that's it. That whole thing has been simplified. Okay, so this example, or this idea, would be rewriting the identity using a single function of x. So let's look at another example then where we're going to be applying that sum and difference identity. We did a similar example to this in the previous lesson 5.3, where I'm going to find what the sine of s plus t is, and I'll go ahead and find what the sine of the tangent of s plus t is. And I'm only given this information here. Well, when I think back to let's go back and look at this real fast. If I'm going to end up finding the sine of s plus t, then I need to know not only the sine and cosine of s, or the first angle, but I need to know the sine and cosine of the second angle. So I'm going to need to find that. And then for the tangent function, I just need to make sure that I have the tangent of both angles. So scrolling back down, what that basically tells me is on just here, this S angle, I'm going to end up finding the sine and tangent of S. And for my T angle, I have to find cosine and tangent of t. Now S and T, both of these angles are lying in quadrant 1, so I know that all of my angle values are going to have a positive sign. So we go back and we say, okay, well the cosine is x over r. So if x is 3, r is 5, and I don't know, I hope you remember that we have that special 3, 4, 5 triangle. So that would make y 4. If you didn't remember that special triangle, you could still use Pythagorean's theorem to solve for this missing side. Now, having said that, I'm supposed to be finding the sine and tangent. Well, sine is y over r, sorry, so that would be 4/5. Let me write this. The sine of S is 4/5, and the tangent of S is going to be y over x, which is 4/3. Let's go do that again over here. So in this case, since I know what the sine is, I know that the sine is y. So y is 5, r is 13, and x is going to be, remember we can use Pythagorean's theorem, and it's going to say the square root of r squared minus y squared. That's going to be 13 squared minus 5 squared. Well, that's 169 minus 25, which would be the square root of 144, which is just 12. Okay? I don't know if you remember or not, but this 5, 12, 13 is also a special angle. Having said that, I can now come up with the cosine of t, which is going to be x over r, and the tangent of t, which is going to be 5 over 12, 5/12. So I know all 4 components, or I guess 6, that I need to be able to simplify this or solve it. So if the first question says I want to find out what this is, then I use the sum identity for sine. Let's rewrite that. It's the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. Well, the sine of S, we just calculated that out to be 4/5. The cosine of T, we just calculated out to be 12/13. Now the cosine of S was given to us. That's 3/5. And the sine of T was given to us also. That's 5/13. Okay? So let's simplify this. It's a pretty easy problem to simplify in our calculators. I'm going to pull that calculator up and use the math fraction button. So this is going to be 4/5 times 12/13 plus 3/5 times 5/13. Math frac enter. And there's our answer, 63 over 65. Okay, so I want you to take a second and I want you to do the tangent of S plus T using all that information that we just got. So stop the video, work it on your paper, and then let's come back and make sure we get the same answer. So when I take the sum identity for tangent, break it out and replace those values with what we just calculated, you end up getting 63 over 16. So I hope that you can get that value using your calculator. If not, keep practicing it until you can get that. Okay, so that's how we're going to apply some of these, both the sine and tangent identities we're learning today.